Jai Hind all of you. Today we are going to study a new chapter, chapter 3, motion in a straight line. Motion, that is change in position of an object with time. Study of motion is known as kinematics. Classification of motion: one-dimensional motion. Straight line motion or the rectilinear motion is the one-dimensional motion. Motion in a plane is the two-dimensional motion. Motion in space is the three-dimensional motion. So this chapter explains about the one-dimensional motion. Now we are going to study about some physical quantities in this chapter. The physical quantities are divided into two, that is scalar quantity and the vector quantity. Scalar quantity means the physical quantity which has magnitude only, that is numerical value. For example, distance, speed, work, etc. Then vector quantity. Vector quantity means the physical quantity which has magnitude and direction. For example, displacement, velocity, acceleration, etc. Let us see the distance or the path length and displacement. For example, consider an object moving from initial position A to final position B. So, this is the two path followed by the particle from initial position to final position. So, this is the actual path followed by the particle from initial to final. So, it is known as the path length. So, path length has only magnitude, it has no fixed direction. So, path length is a scalar quantity. And if the object moves through this straight path, that is the shortest distance between the initial and the final point. So, it is the displacement of the particle. So, this displacement has magnitude and it has a fixed direction. So, it is a vector quantity. In one dimension, to represent the position of a particle, we need any one set of axes, either x-axis or y-axis or z-axis. So, if you choose x-axis, we should represent the initial position as x1 and final position as x2. So, change in position of the particle, that is known as the displacement. So, to represent this displacement, we use the representation delta x. Delta represents change in quantity. So, change in position, that is equal to x2 minus x1. So, x2 is the final position and x1 is the initial position. So, change in position is equal to the displacement. If x2 is greater than x1, then displacement delta x equal to positive. If x2 is less than x1, then displacement delta x equal to negative. Consider another one example. If a car moves on a straight line, we can represent it on a x-axis. So, if the car moves from O to P and then reaches the point Q, then returns to Q and moves in the backward direction. We can consider some cases and find out the path length and the displacement. So, first case, if the car moves from O to P, what is the path length and the displacement? So, we can note the path length, that is O to P. What is the total distance travelled by the car? That is plus 360 meter. And what is the displacement of the car? It is the shortest distance between O and P. That is also equal to 360. Okay, that is the displacement. And in the second case, we can take the car moves from O to P, then back to Q. Then what is the path length travelled by the car or followed by the car? So, O to P, that is 360 meter. Then back to Q, that is 360 minus 240, that is 120. So, what is the total distance? That is equal to 480 meter. Then what is the displacement? Displacement is the change in position from initial to final. So O to P and back to Q. So this is the initial position and this is the final position. So what is the change in position? x2 minus x1. So 240 minus 0, that is equal to 240 meter. Then in the third case, car moves from O to P and returns to O. So what is the path length? So O to P then returns to O. So what is the path length? 360 plus 360, that is equal to 720 meter. Then what is the displacement? So what is the displacement? O to P then returns to O. So what is the distance, the shortest distance between initial and final position? That is equal to 0. In these cases, in the first case, the path length and the displacement is equal. In the second case, path length is greater than the displacement. In the third case, path length is equal to 720 meter but the displacement is 0. So, in this third case, displacement is 0 but the corresponding path length is not equal to 0. But when the initial and final position is same, then path length and the displacement is 0. If the initial and final position is same, then the path length and the displacement is equal to 0. Here the car moves from O to P then returns to O. So path length equal to total distance travelled by the body and the displacement is equal to 0. Then fourth case, the car moves from P to Q. Car moves from P to Q. So what is the path length here? Path length equal to 360 minus 240, that is equal to 120 meter. Then what is the displacement here? Displacement equal to final position minus initial position. So that is 240 minus 360, that is equal to minus 120 meter. So this minus sign represents that the car moves in the backward direction. Okay. So we can see the difference between the path length and the displacement. So path length is the actual path followed by a body between its initial and final points. Displacement is the shortest path between its initial and final points in a fixed direction. Then path length is a scalar quantity, displacement is a vector quantity, and the unit of path length and the displacement is meter. And path length, the magnitude of path length may be positive or 0. Magnitude of displacement may be positive, negative or 0. Then one more point is there, the magnitude of displacement may or may not be equal to path length traversed by the object. Another two important terms are average speed and average velocity. So what is average speed? It is the total path length divided by total time interval. Then average velocity, it is the displacement divided by time interval. So average velocity is noted by a letter V bar. Then displacement, that is x2 minus x1, and time interval t2 minus t1. For example, when an object is at position x1 in a time t1, then after moving through a distance it reaches the point x2, then the time becomes t2. So what is the change in position? X2 minus x1. So what is the change in time interval? That is t2 minus t1. So this ratio is known as the average velocity, that is v bar equal to x2 minus x1 divided by t2 minus t1. So x2 minus x1 is noted as delta x, change in position. Similarly, t2 minus t1 is noted as delta t, that is change in time. Then unit of average speed and average velocity is meter per second. Then according to or depending on the path length, average speed may be positive or 0, and depending on the displacement, average velocity may be positive, negative or 0. So negative sign represents that the direction of the object. Another important term in this chapter is average acceleration. So average acceleration is denoted by the letter a bar. So it is equal to the change in velocity by time interval. So change in velocity is v2 minus v1, where v1 is the initial velocity at time t1 seconds and v2 is the final velocity at a time t2 seconds. So we can write v2 minus v1 divided by t2 minus t1. That is equal to delta v by delta t. So delta v equal to change in velocity by change in time. So its unit is meter per second square.